Good day to you all. I hope you are all doing well at home. Okay, we want to continue from where we stopped on integration, and in today's lesson we'll be looking at evaluating constants of integration. And don't forget, in our indefinite integral, we talked about anytime we integrate a particular function, we always end up having plus c. So how then do we get this c? That is the main thing we want to do in today's lesson. And the objectives are, you should be able to evaluate constant of indefinite integral, use the concepts to determine equation of a curve, and at the same time you should be able to use the concept of motion of an object. Okay, if a point on a curve is specified, that means on a curve, let's say for instance we have this curve, and a point on it is specified with its coordinate, then the value of the arbitrary constant c can be evaluated, and that is what we want to do. Let's quickly look at this example together. The question says here, the gradient of a curve at any point is given by 3x squared plus 4x minus 5. And the question says, determine the equation of the curve at the point 2, 5 lie on the curve. Now what do? We all know what gradient of a function is. Gradient simply means change in y with respect to x. That simply means to have this one solved, we can have dy dx is equal to, we're given the gradient to be 3x squared plus 4x minus 5. Okay, we want to get the value of our y. We can have this one over 1 and we cross multiply. To have that, we have dy is equal to 3x squared plus 4x minus 5, all in brackets, then dx. Of course, we are looking for y. Then we introduce our integral sign to both sides. So having that done, integral of dy will give us y as a function, which is equal to, if you go by the method of integrating polynomial, we're going to be having this one to be 3s raised to the power 2 plus 1, then over 2 plus 1, and plus 4s raised to the power 1 plus 1 over 1 plus 1, then minus 5 s raised to the power 0 plus 1, 0 plus 1. Of course, this will give us, don't forget when we are integrating indefinite, we introduce our constant of integration. This will give us 3s cubed over 3 plus 4s squared over 2, and then minus 5s plus c. Okay, you agree with me that this 3 will nullify 3. That means we have our y to be equal to s cubed. Okay, plus 4s. This 2 also will go in 4 in 2 times. So we are left with plus 2s squared, then minus 5 plus c. Now, the question says if it passes through 2, 5, that means our value of s is 2 and the value of y is 5. So let's introduce that. We have 5 is equal to 2 raised to the power 3 plus 2 into 2 raised to the power 2 minus 5 into 2, then plus c. So we can have our 5 to be equal to 2 raised to the power 3 will give us 8 plus 2 times 2, that is 4 times 2, that is 8, minus 5 times 2, which is 10, then plus c. We have this to the 5 is equal to 8 plus 8 will give us 16 minus 10 plus c. 16 minus 10, that is 6. And that means we have 5 is equal to 6 plus c. When 6 comes to this side, we have minus 1 is equal to c, meaning that our c is equal to negative 1. And of course, we get the real value of y now. Don't forget that this is y. Our y now becomes s cubed plus 2s squared, then minus 5x, plus what is our c? Okay, let's say minus 5x, then minus what? 1. Okay, and this is the function whose gradient is going to be this. Once we understand that, let's quickly look at this. On the motion of object, we can also apply this. Of course, we know that velocity is always displacement over time, meaning that our displacement is going to be integral of velocity with respect to time t. Okay, also acceleration is change in velocity with respect to time, which is talking about second derivative of velocity. That implies that our velocity is equal to the integral of acceleration. Now let's look at this question and now we can apply what we have just been taught. A body moves in a straight line from point O with initial velocity 3m. Don't forget that initial velocity is talking about when the body is at rest. The velocity. Its acceleration is at t seconds later is given by, we have our acceleration to be 40 minus 5 in meter per second square. We are now being asked to find the velocity of the body after 4 seconds. But we know that velocity is equal to integral of the acceleration with respect to time t. So that means our velocity is going to be integral of 40 minus 5, then the t. And this will give us 40 squared over 2 minus 5t. And of course, this will cancel this one, this will cancel this. Don't forget your plus c. At the end of everything, you are going to be having 2t squared minus 5t plus c. And of course, we are given that at initial velocity, time t, the velocity is 3. When t is equal to 0, that is at initial velocity, the time is equal to 0. So we now have our velocity, which is 3, is equal to 2. That time will be equal to 0 squared minus 5 into 0, because time is equal to 0. So we have this one to be 3 is equal to, everything here comes to 0, then c. That means c is 0. Then we have the velocity at that point now to be velocity is equal to 2t squared minus 5t. Then what is our c? Plus what? 3. And this will give us the velocity of that same body. So many of the examples on this will be sent to you via the Google Classroom as usual, and feel free to always send your comments as to the video. Have a nice day. Bye.